Hello, you're welcome back. We are going to be solving more questions on the second order differential equation. So I have another example right here. Okay, so we are to solve d square x dt square minus 4x is equal to 24 cos 2t. Alright, so let's begin. So the initial value condition has been given at t, of course, at t equal to 0. We have that x is equal to 3, then the s dt is equal to 4. So let's transform this equation into its Laplace equivalent. All right. So let's start with d square x. You know exactly what is going to be. So that's going to be x square, then x bar minus the x reduces to 1. Then we'll now have x0, okay, minus the x reduces the power of the s reduces to 0, which makes it 1. Then this one, x increases to x1, okay, that is it. Then minus 4 x bar equal to the Laplace transform of 24 cos Laplace transform of cos 2t is definitely gonna be x all over x square then plus 2 square, which of course is 4. All right, so let's work on this. Collecting like terms together, so my x bar, okay, if I factorize it, I'm going to have s square, of course, minus 4. Now I take the other terms to the other side, and of course I will insert the initial value condition. So of course this is going to be 25x s square plus 4. Okay, so the initial value of x0, so at t equal to 0, s is equal to 3, that is my s0, that is 3. So here I'm having 3x. Then of course the x dt is 4. Here I'm having 4. So I'll take this 2 to the other side of the equation. So minus, this is going to be minus goes over becomes plus 3x plus 3x. Then of course minus 4 goes over becomes plus 4. All right. So let's simplify that fraction at the right hand side. The LCM, okay, equal to, of course, the LCM is s square plus 4. So here I'm having 24x plus 3x into s square plus 4. So I can open that bracket. So that's going to be 3s cubed. 3s cubed, then plus 12x squared. That's going to be plus 4x squared, then plus 16. Okay, so of course you know exactly what I did there. Okay, so of course to make s bar the subject, this will come, I bring this to the denominator, that's going to be s squared minus 4. All right, so this is going to be x bar equal to, this is known as the difference of 2 square. Difference of 2 square. So invariably, the denominator is difference of 2 square. So what I'm going to do, of course, let me collect like terms here. 3s squared plus 12x squared. Okay? It's like I made a mistake somewhere. This was supposed to be 3s cubed minus is s cubed. This was supposed to be 3s cubed, not s squared. Okay, then of course 3s cubed plus 12x squared. All right, so collecting like terms together, I have 12s squared plus 4s squared. That is gonna give me 16x squared. All right, so this is going to be 24x plus 3x cubed plus 16x squared plus 16. Then difference of 2 square. So this is applying difference of 2 square. That is going to be x square all raised to the power of 2, which is s raised to the power of 4. Then minus 4, of course, square. 4 square is 16. Okay, so do I really need to apply the difference of 2 square? Is that necessary? Okay, no, not necessary. As let me still have to write it the way it is. Okay, it's not necessary. So all I just need to do is to transform this into the of course, find the inverse Laplace transform of both sides of the equation. Okay, so this is inverse Laplace transform of 24x plus 3x cubed plus 16x squared, 16x squared, then of course plus 16. Then all divided by s squared plus 4. Then of course s squared minus 4. Alright, so you know what we need to do? Work on this partial fraction. So working on that partial fraction, of course, let me go straight. I cancel out the denominator. Okay, let it be that the denominator have been cancelled out. Okay, so for the numerator, you know how it goes. This is a quadratic factor, this is a quadratic factor. So this is going to be ax plus b divided by ax, please, this ax plus b divided by s squared plus 4. Then plus the same thing here. This time around, this is going to be cx plus d divided by s squared minus 4. Alright, is equal to let me write it down. This 24x plus 3s cubed plus 16 s squared plus 16, then divided by s squared plus 4, then s squared minus 4. So splitting that into the partial fraction equivalent. Alright, this is going to be a all over ax plus b all over s squared. I'll keep on using x, so it's supposed to be x. Okay, so right, here we go. So s squared plus 4, then this is cx plus d, which cx plus d divided by s squared minus 4. All right, so working on that on the fraction. Okay, so of course, let me go straight to the fraction. So this is going to be, of course, I have to, let me cross multiply. ax plus b, then multiply by s squared minus 4, plus cx plus d, then multiply by s squared plus 4. s squared plus 4. Alright, so of course the denominator will cancel out. So I bring this down, 12x plus 3x cubed plus 16x squared plus 16. Alright, so let's do this. So for me to eliminate, I can eliminate. Okay, so what can I eliminate? Okay, as a matter of fact, if I eliminate this, I'll still have cx plus d. So what I can do is simply I will equate coefficient. So let me expand. Expanding this, I'm going to have ax cubed minus, of course, 4ax. Then I have bx squared, then minus 4b. Plus, if I expand this, I'm going to have cx cubed plus 4cx, then plus dx squared plus 4d. Alright, so I can go directly to compare with coefficient with the left hand side. Okay, so let's compare coefficient. So what I would do in this regard is, of course, the coefficient of s cubed, which of course is a plus c. Okay. All right, yes. The coefficient of s cubed is a plus c. So invariably a plus c is equal to 3. I call that equation 1. All right. So the coefficient of x squared. Coefficient of s squared, so I have b plus d. B plus d is equal to 16. I'll call that equation 2. All right, let's look at the coefficient of x. Minus 4a plus 4c. Minus 4a plus 4c. All right. Of course, it's equal to 24. Okay. So I'll call this equation 3. Now, if I consider the constant value, or constant, minus 4b plus, okay, minus 4b all right, so minus 4b, of course, plus 4d is equal to 16. So just a way of combining this equation to just solve for the 3 variables, okay? So you can do it any way you wish to do it. So there are 2 ways I can actually do it. I can combine equation 1 and equation 4. Equation 1 and of course equation 3 having the same variable. Then I solve it by elimination. Okay, so what I can do is I can simply say from equation 1, if I make a the subject, a is equal to 3 minus c. So if I substitute that, a equal to 3 minus c into of course, equation 3. So I'm going to have minus 4, then 3 minus c, then plus 4c is equal to 24. Let's open this. This is going to be, of course, minus 12 plus 4c plus 4c equal to 24. This is 8c. 8c is going to be equal to 24 minus 12. So let's do that. 24 minus 12 is 12. And of course, divided by 8. 4 into 12, of course, I have 3. Then I have 2. C is 12 over 3. Okay. So having gotten C, alright, I can also find A. So I can find A here. So invariably from equation 3 2, I have minus 4A is equal to minus 4A, right? Is equal to 24 minus 4C. Minus 4 is equal to 24 minus 4C. That is 4C, which is 4 all over 2. So this is going to be minus 4A. 4 divided by 2, that is 2. So I'm going to have 24. 2 times 4, 24 minus 8. Okay, so 24 minus 8 is 16. So invariably A is going to be minus 16, of course, all over 4, which is minus 4. I've gotten my A. So how can I solve for B? Alright. So since I've gotten my A, I can actually solve for B. Okay. Okay, so B plus D is equal to 16. I need to solve for B. So what I can do is here I have, okay, so I have minus 4B plus 4D. That's the two constant terms. That's the only place. Okay, B also appeared here. I made a mistake. B appeared as as a coefficient of S squared. So B plus D as a coefficient of S squared. Then of course B plus 4D, okay, as a constant term. So invariably I can combine those two. I can combine equation 2 and equation 4. So what I can do now, I will say from equation, of course, 2, B is equal to 16 minus D. So from equation 2, okay, from equation 2, B is equal to 16 minus D. So what I will do, I will substitute B equal to 16 minus D into equation 4. So let's go to equation 4. So equation 4 I have minus 4B, okay, plus 4D. That's going to be equal to, okay, so that's going to be equal to minus 4 into 16 minus D. All right, then plus 4D. This will be equal to 16. So let's open up this. Of course, 4 times 16, that should be 64. Am I mistaken? Let me find out. 4 times 16. 64. That is, here I'm having minus 64 minus 4d plus 4d. Okay, plus 4d, of course, plus 4d is equal to 16. So take it to the other side. I'm going to have 16 plus 64, 80. So 8d is equal to 80. So invariably, okay, so d will definitely be 80 all over 8, which of course is 10. D is 10. So of course b now will be b being equal to 16 minus d. That's 16 minus 10, which of course is 6. So I've gotten everything that I'm looking for. So let's get straight to the inverse Laplace transform so that we can conclude our answer. So our equation S is going to be equal to the inverse Laplace transform of the partial fraction a, which of course ax plus b all over s squared plus 4. So what's my a? Okay, my a is minus 4 minus 4x plus b plus 6 all over s squared plus 4. All right, then plus cx plus d. What's my c? Okay, c, that's 2 all over 3. 3 all over 2. 3 over 2x plus d, which of course is 10. Then divided by s squared minus 4. All right, so to conclude this, we have to find the inverse Laplace transform of this. So it becomes tricky because at this point, this would have been the inverse Laplace transform of sine or cosine, but because of the minus 4x plus 6, all right, we have to do something to this, okay, which I'm going to show you in the next video. This would have been the inverse Laplace transform of cos, all right, but because of this that is included to it, then we have to do something to it. Okay, so now I want you to brainstorm of what we are going to do to this so that we'll be able to transform into our standard inverse Laplace transform. All right, so we are going to conclude this in the next video. So see you in the next video. Thank you very much.